Hello, everyone. Today we're going to be doing the stopwatch using the Arduino. And so for our project here, I'm going to have two screens. So I'm going to be going over from one to the other. And this will have two functions within it, start and pause. And so we're going to count up to, the device it's, if you look here, 23 hours, 59 minutes, and 59 seconds. So you could count up a full day if you want to. And so we're going to be walking you through each of these individual steps, and then we're going to actually implement it. So for the introduction, we're going to have our stopwatch using the Arduino can start and pause. It counts up to 23, 59, 59. And the start button is used to start the stopwatch, and the pause button to pause the time. And it can resume count by pressing the start button again. And so for the Uno, we're going to be using the Arduino Uno board. This one you'll use a lot in your intro EE classes, and it offers open source hardware and software. It's easy to use for projects. We have 14 digital pins, and so you guys can see the digital pins are on this side of the board, and we have 3 ground pins, one here, and then we have another 2 located on this side, you'll see. And then we also have a 5-volt pin located on this side and a 3-volt pin as well. And so within this device, you're able to have a variety of power and ground sources. And so we're going to be walking you through it. And then also to notice on this board, pin numbers 2, 3, 4, 5, 11, 12 are used to interface with this crystal display. And so, for the liquid crystal display, it's going to have 16 characters on each row, and it's going to have 2 rows. And so that's going to be 32 total characters, 16 times 2 on that liquid crystal display. So it's going to look something like this if I'm going to show you guys. Here, I'm going to draw a rectangle. And so there will be 16 characters on this first row and another 16 on the second row. And so that's what our liquid crystal display will look like. And then pin number 8 is used for the start signal from the push on the button. So we're going to have a push button to start it. And then we're going to have pin number 7 used to pause. And so that's going to have another push signal on the button. And so we're going to then walk you through how this display works. So as I told you guys before, we had a crystal display, and on this display, it has 16 pins. And we're going to use 12 of the pins from the display for interfacing with the Arduino. It has 8 data lines as well, and we use data line 0 through 3. And so you guys know, we're going to have to make this circuit diagram. And so we'll walk you through this, but this is just the overview of what your circuit will look like. And then we have this code you'll have to implement in the Arduino IDE. And we're going to walk you through each specific step here. And so we're going to get to the actual construction of the project. So as shown in this circuit diagram. So I'm going to give you a little overview here. So as you can see, you need an Arduino Uno board on the left-hand side. So I'm going to show you what my Arduino board looks like. Mine, as you can see right here, has the actual board. So that's what we see right here on the left on the circuit diagram. So I'm going to change colors. You guys can see this over here. This is what you need. And then we're going to have to need a breadboard. So right here. So get out your breadboard. I'm going to show you guys mine. And so you guys can actually see what it looks like as we covered in one of our previous videos. And so I have my breadboard right here, and I'm going to use that to insert all the pins in. Okay, so now what I'm going to do, that I have my breadboard, I have my Arduino Uno. Now I need to get my liquid crystal display. So for my liquid crystal display here, I have the 16 by 2 right here. This is just a loop protected piece over it. That's the board I'm going to be using with the pins on the back side. We're going to need 2 push buttons here. You guys can see 1, 2. And so for the two push buttons I have right here, 1 and 2, got two push buttons. And we're gonna need 3 resistors. So 1, 2, 3. And so for these resistor values, we're going to have to look at which ones they used within the actual circuit. Oops, sorry. And it looks like for their resistor values, it goes red, red, and brown. And if we remember from our color code that we went over, red, red, brown is 2, so 2 times 10 to the 1. So that would be 22 times 10, that's 220 ohms. So you're gonna need those type of resistors within your circuit. And so now that we know that, we're going to set this up. And let's find out how many cords we're going to need. There's one here. So let me get you. We have one cord here, another here. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to need 10 jumper cables. So I'm going to get those. Mine look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Got 10 jumper cables. Now we need to determine how many of the small little jumper wires we need. So I have one here, 2, 3, 4, 5, 6, 7, 8. And so we need 8 of those. And so when I go to my collection here, I'm going to choose 8 of these. So let me get these out. So I have 1, 2, 3, 4, 5, 6, 7, 8. I will show you guys what they look like. Here they are. So mine look about this size. They're smaller, so those will be our little jumper cables we'll use within the spreadboard. And now that I've gone over those two, we're going to actually implement it. So the first thing I want you guys to do is we're going to hook in this 5-volt pin from the Arduino here and this ground pin from the Arduino. And we're going to hook those up to the breadboard to the bus terminals. So this red one and this blue one here. When I do that from my Arduino Uno over, it's going to go, so you guys know, from the 5-volt pin on the Arduino. So I'm looking here. I see 5 volts on the side here. I plugged it into the 5-volt pin. And then on my breadboard, I'm going to plug it into the red terminal here. So I'm going to plug it in right up here to the red bus terminal. Now I'm going to do the same thing, but connect the ground on the Arduino. So connect the ground, which is right next to the 5-volt pin, and connect that to the negative bus terminal on the breadboard. Now that I have done that, I'm going to connect all my other pins here. So 12, I can see pin 12 goes to 1, 2, 3, 4, the 4th pin on the liquid crystal display. So connect those up. So put your liquid crystal display in your breadboard. So when I connect it with my breadboard, I'm going to show you guys what it looks like on my side, so you guys have a good understanding of what it should look like on yours. And so when I plug it in here, mine looks about like this when I plug my liquid crystal display in. And now I'm going to connect up those wires like I told you. So I told you guys pin 12 on the Arduino Uno on the digital side is going to go to the 4th pin over. So 1, 2, 3, 4, 4th pin from the left. Okay, now that we've done that, we're going to do the next two. So pin 11 on the Arduino is going to go to the 6th pin on this liquid crystal display. So from pin 11 to pin 6. Now that we've done that, pin 8 is going to go on our push button here. So we're going to have our push button. You'll see it has 4 sides to it. On a push button, I'm going to draw it out for you guys right here on the bottom right. Let's see, hopefully it's lagging a little today, my marker, so there we go. Okay, so we have 2 on one side and 2 on the other. And so these 2 are connected to each other and these 2 are connected to each other. So you have to be careful on the push button. So when we put our push button in on the breadboard, one of these, they're going to be on the same, that's going to be hood. Okay, they're going to be on the opposite side, so you got to be careful. This push button laid out, it looks like, okay, sorry, this delay, let me re-annotate so I can change the color. Okay, so you're going to want these 2 on this side and the other 2 on this side. And this one's going to be hooked to ground, so to the blue, while the other is going to be hooked to, oh, sorry, this is going to be hooked actually to power. And the other is going to be hooked up to a resistor, which is hooked into the ground pin. And so you can see that up here. So I'm going to erase that real quick. You can see how we're hooking this one in here to that one corner, and that's going to have the resistor, and it's going to go to ground. While the other one is going to be hooked to power. So on this other side here, because we have 2 and 2, this one's going to be hooked up to the power supply. So let's put that in our board. So going from pin 8 here all the way to this. So let me go from pin 8 all the way over to this side of the push button. And then remember to hook up your 220 ohm resistor. And I will be right back. I need to go get my 220 ohm resistor, so give me 1 second. Okay, so for my 220 ohm resistor, I'm gonna hook that up on the other side. And so remember, 220 ohm is red, red, brown. When I'm looking here, red, red. Okay, got it. And we're gonna hook that up to the 5 volts and on the other side of the switch push button. Okay, so I have that connected. Okay. Now that we have that connected, we're going to go over to the next one. So let me clear. And for our next pin, it's going to be from pin 7, and it's going to go down to this other push button we have on this side. So for this push button, it has its 2 on this side and the other 2 on this side. You're going to do the exact same configuration here. So put in your push button on the opposite side of the liquid crystal display. And then you're going to hook up pin 7 to one side of it. So we have pin 7 from the Arduino. And I'm going to hook that up to one side. And then you're going to hook up the 220 ohm resistor, which we have here, 220 ohm. And hook that to the 5 volt, to the ground, not the 5 volt. Okay. And once you do that, I'll give you guys 1 minute to catch up here. Let me- Okay, once you guys have finished that, now I'm going to show you how to hook up the next part of this. And so now that we have the two push buttons connected, we're going to see this pin 5 here is going to go directly to the 6th pin from the right. So hook those from pin 5. Okay, now that we've done that, we're going to go over to pin 4. And so we have pin 4 here, and pin 4 is going to go to the 1, 2, 3, the 5th pin from the right. Okay, so let me connect that one up. Okay, and then we're going to do the 4th pin from the right is going to be connected to pin 3 here. You can see if I have a longer wire, that might be better. Okay. Now we're gonna have to connect pin 2 to the 3rd pin from the right. Okay, now that we have finished all that, we're going to be going over how to do the other interconnections within our circuit. And so as you can see, within the circuit, there's another part we have to complete. And this part entails all the inner circuitry here. So let me take off those two. We have to connect now these small little wires. So we'll go one by one, get those all connected up. And then we'll have one other resistor here. So let's go from left to right. We're going to have one going from the ground to the first pin on the left of the LCD. Okay, now that we've done that, we're going to connect the second one from power to the second pin on the left. And you'll notice it will get harder with all the pins getting right next to each other. So once we do that, and then once we do the other one, okay, got ground and power. Next one's ground to the third pin. Okay, after we did ground to the third pin, we're going to do ground to the fifth pin. And then we're going to be doing ground to the rightmost pin. And then we're going to have the second to the right all the way over here. And this one's just going to connect to another 220 ohm resistor and connect that to power. Okay, so we'll be connecting this one here, the resistor, and the one connected power. So, okay, once you got all those connections made on this diagram, we're going to put this on the Arduino IDE. And so here's going to be the code we're going to use. And so I'm going to switch displays. I'm going to stop on here. And I will turn this off. And so now I'm going to start sharing my screen here. So I am on the website. And so this code I got, this is just from Kio. So I'm copying that over. And I'm going to walk you through each of these. So this one here, this code is for the liquid crystal display. I think comments in this program are this thing. And then here, this one on the liquid crystal display, this matches, if you see right here, if you guys are ever unsure, which is a nice thing to know of, you can look up what does liquid crystal LCD do? And so when I do that, you can see if you ever don't know anything, which will happen a lot, just type it up here and then say function Arduino. And they will have it on the Arduino right here to tell you what it does. And so they say the liquid crystal, it's controlled using 4 or 8 data lines. And so that's nice to know. So you know those are the specific data lines this liquid crystal display uses. And so we know right here, we can say these are the data lines. And the setup code, this is going to run once. And it's going to start up the LCD, which has 32 characters. It has 16 characters and 2 rows for those characters. And then we're going to clear the display, so there'll be nothing displayed on it. This is setting the baud rate. So 9,600 bits per second. And then here we have pin mode 8 as an input on the Arduino. So Arduino pin 8 is an input. Then we're going to be giving pin 8 is set at high, which is the equivalent of 1. And then Arduino pin 9 is an input. And pin 9 is set at high, 1. Okay, here's where we're going to have some variables. So remember doubles, what they do is they can store integer value, decimal values. And so we have I, variable I as a decimal. And then we have a variable, we start it and initial value is 0 up here for I. And then our next one is going to be variable A. And it's going to be a decimal as well, you can tell. And it has the function millis on it. And you're probably wondering, what's millis? Well, in order to find out what millis is, just search up millis Arduino. And so you know, is millis returns the number of milliseconds passed since the Arduino board began running the current program. And so that will tell you how much time has passed since the program has been running. And so I'm going to put right here, tells you how long the program has been running. Okay, and this is variable C as a decimal. That's basically because it's a double. It has no initial condition. You didn't assign anything to it. And so this loop is going to run over and over again. Clear the display at the start of the loop, and then display, press start. And you're going to delay for, and this is in milliseconds, so 100 milliseconds is 0.1 seconds. If pin 8 is low, so 0, then we're going to clear the LCD display. And you're going to set A equal to the number of milliseconds that have passed since the beginning of the program. And once we do that, this is a while loop. So while this condition is true, it's going to execute the code under it. So while pin 9 reads in high, so value of 1 is coming in, so it's on, set C equal to the time that has passed since the program has been running. And then here, you're going to take C minus A, so the time that has passed since the program has ran. And so that would be C minus the other stored value of when the program ran. So that was in the beginning. And divide that by 1,000, because we're in milliseconds, and set that equal to I. And so that's going to display the current time. So that this will calculate the time that has, and this will display the time on the screen. set cursor 7, 0. That basically means for set cursor, so you guys know, because if you look on set cursor for the liquid crystal display, the set cursor is, it positions the LCD cursor. So it's the location at which subsequent text is written to the LCD. So it's column, comma, row. And so in our code here, it's going to be column 7, row 0. So that's going to be at the 7th character over on the first row. That's where it's going to happen. And it's going to print seconds. You can see right here, so seconds. And then this is going to be column 0, row 0. So on the first space in the first column of the first row, it's going to print the value of C. And then it's going to, so that was how long it took until C got executed. Print the value of A, so how long it took until A got executed. Then print the value of I, so when that calculation got created. And then print ... at the end. And then wait 100 milliseconds, which is the equivalent of 0.1 second. And so now this is if digital read 9 equals low. And so we talked about these two, which digital read 8 here and digital pin 9. And if you remember from our Arduino diagram, let me pull it up for you from the link Keo sent. He knows how to do this. He'll show you the Tinker model after. And so for this one right here, for the stopwatch using the Arduino, we have the actual pin numbers. So you can see where pin 9 and 8 come from. And so when we were talking about this in our code, we can see pin 8 here is at this one right here. So this pin is connected to, so let me draw here. This pin is connected to this push button. And then we had pin 9. Okay, Keo, you're in the call. I think pin 9 was meant to mean pin 7, right? For the other one here.
Yeah, sorry.
So for your guys' code, the only thing you'll have to adjust here is wherever it says 9, replace that with 7. So let me go back and just do Control F and then say 9. Replace that with a 7. And so what's going to go is it's going to go through in any instance where it saw 9, where we accidentally set that, it's going to give it a 7. Okay, so find. And so when we find it, nope, not that one. So we want to find the next. It looks like, nope, not that 9. This one, yes, we're going to want to replace. The next one we found, yeah, replace this one, replace that one, replace that one. Okay, there's all the cases we needed to fix. So we matched those up. So it's good we verified it against the actual scheme, the actual circuit diagram. And now we're going to go, so if pin 7 is low and pin 8 is high, so that means the other push button was activated. So push button low, this push button is low. However, this push button is high, so you hit this one. On the cursor, you're going to start at the first column, first row. And you're going to print the value of I. Oh, I see we got a chat here. Oh, thanks for sending that updated code. And then here it's going to be column 11, row 0. And we're going to print just an empty space, and then go back to the first column, first row. and wait for 100 milliseconds, which is 0.1 seconds. Okay, now that we've written all the code, we got it all fixed here. You're going to upload this to your board. So in order to upload this to your board, you're going to go to verify right here. It's going to check if your code actually works. So I need to save this. So I'm going to save this on my desktop. And I hit verify, and it gives me an error. It says there's something wrong here. Oh, I noticed right here I have a V. I should get rid of that because in your code, you should not have anything after the semicolon except comments. Okay, it's compiling. You can see down here, it says it's done compiling. And I want to make sure I upload it to the correct port. So the Arduino Uno is selected. And for my port, I need to actually connect it to the computer. So I'm going to connect the one end into my Arduino board. And the other end is going to go in the USB port on my computer. And you can see when I do that, when I go back to port, it says COM3, Arduino Uno. So after I hit compile and after I hit upload to the board, it uploaded to the Arduino Uno board. And then you'll be able to get the result from it.
Is it working?
I'm going to show you this video real quick because Keo, do you have yours assembled or?
Yeah, I can switch.
Okay, I'm
my
going to let
phone.
you show yours real quick to show the implementation. So I'm going to stop share and I'm going to let you go on. And you can show them the implementation and show them your Tinkercad. Okay, so I'm going to push it off to Keo now. And so Keo, you might have to turn on your camera to show them the actual implementation.
Yeah, I'm joining on my phone.
Okay.
Hello.
I'm going to turn off my microphone so you become the main screen. And so I'll spotlight you for everyone. There we go. Okay, so you can see Keo's stopwatch. So he has it there. So he has his camera. So he uploaded the code to the board and it says press start.
So can you hear me?
Yes.
Okay. So I press start. Well, it's in seconds because we're using millis. And if you want to stop or pause it, press the right one. I can't go back or continue the time. I need to modify the code. I can only go back from the start again. Also, potentiometer to lower the brightness and increase the brightness. Yep. There you go. Thank you.
Okay, now do you want to show your Tinkercad model?
Yes. Okay. I'll share it.
And so now you guys saw the implementation of the stopwatch, and now he's going to be sharing his Tinkercad model with you.
Can you see it?
Yes.
For this one, there's no start and stop buttons. So we just start we just run it, and it will show you there. This is the milliseconds. It's really slow. It's the Tinkercad software. Basically, this is how it works. And then if we press this one, it will go back from the start. It's basically the reset button and potentiometer for the brightness. It acts like a resistor. That's 1 second. Okay. We can always change the code here. Oh, this is the code. I'll share it. Thank you, Brian.
Okay, and so that will conclude what we have today, and then I will upload the video. So thank you all for joining, and that will conclude our first project. And I will stop